Hello everybody, welcome to your tutorial on correlation. Correlation analysis is when you are going to be testing a hypothesis between two variables that are either interval/ratio level of measure or ordinal, or some combination thereof. Now, if they're both interval/ratio style variables, you run a Pearson correlation. For anything that involves an ordinal measure and another interval ratio or two ordinals, that's going to be a Spearman correlation. Now, the good news is that the procedure for doing it in SPSS is pretty much the same. Just with a Spearman, you're acknowledging that your data are not interval level, at least, that they are actually ordinal, an ordered list. You don't know the distance between the possible answers. So it kind of corrects for that, but that's really about it. And everything else is the same. Regardless of which one, Pearson or Spearman, you're going to be looking for three things. Significance, which you determine by the p-value of the correlation. The strength, which is determined by the R or the rho. Rho is for Spearman. And the direction. Is it a positive or a negative number, your R or your rho? And that's really just about it. It's pretty straightforward stuff once you get to this point. So, let me show you how to do this in SPSS. We will go to... I'll open an SPSS, and I have my GSS data open, my demo.save file. Now, again, this is data taken from the General Social Survey. Depending on who you're taking this course from, your data may be from a survey that you downloaded from Qualtrics. Either way, it plays the same. All right, so let's get an example going. So let's say I wanted to look at, I'll do two examples here. Let's go with education, and see, education here in the GSS is measured as just years of education from 0 up to 20, however many years you were in school. Because of that, it is an interval or ratio level measure, so that's a good one. Now I got to find us another one here. Let's see here. SEI, it's a socioeconomic index. It's a variable created by the General Social Survey, but it too is just a numeric number given to people to kind of measure class position, social class position. So we'd expect a correlation here, but hey, you never know until you test. So let's do that. Go to Analyze. Go to Correlate. You have options here, but we're just going to use bivariate. Let's keep things nice and straightforward and simple, yeah? All right, I hate it when it gives me the labels here. It makes it look ugly. I right-click on it, and I hit Display Variable Names, and I'm happy again. All right, so to do a correlation, you're just going to toss in your two variables. What did I say? Education. Sorry, I should turn my phone off. Education, and I said SEI, right? That's it. Now, you can put more in here. You know, if you want to put siblings, it's the number of siblings they have. Again, it goes from 0 to however many. Number of children. All these things, you know, they have little signs by them. Age, if we wanted to. You can put many in here if you want. But we'll just do two at first. Then we'll go to another example with more. But just do two here. So we've established both of these are interval/ratio. So we're going to look down here at the correlation coefficients, which says Pearson's, Kendall's, Tau, B, and Spearman. We want Pearson for this. Now you have a choice between two-tailed and one-tailed. Again, there actually is an answer to this, a real one, but if you want to keep it nice and conservative, that you don't mess up and say that things are correlated when they're not, go with a two-tailed test. There's a larger lecture to go with that, but I'll let that go for another time. All right. We have a little box here. Significant correlations will be flagged. There's a little star on there, so in case you missed it. I don't remember if there's anything in options we need. Means and standard deviation. So yeah, go up to options. Right, it's up here. You have means and standard deviations. This is nice. It helps you interpret this later on. And we'll leave it as pairwise for now. We'll hit continue. Hit OK. And it spits this out. All right. So it tells us our average highest year of school completed was, the mean was 13.4. There's SEI, the mean was 48.7, whatever that means, or actually 48.8, whatever that means. But we see here we have our means. Now the question is, are these things correlated? So you get this correlation table down here. Let me see if I can get it closer to the middle of the screen for you. Oops. Guess not. All right. So this bottom box. Now you see here there's actually a bit of redundant information here, right? Because it's high school, highest year of school completed, and SEI versus SEI and highest year of school. It's the same thing. So what you can do is kind of draw in your mind's eye a diagonal line between the ones on these tables and just pick everything either to the right or the left, but not both. Okay? However you want to do it. So we really have one correlation here. It looks like two, but it's actually one. We see that our correlation is 0.601. It has a couple of stars on it. So that's Pearson's R, this first line. All right, Pearson correlation, 0.601. The sig two-tailed, that is actually the p-value, right? So that tells you if it's a significant correlation. And finally, direction is actually in this R as well. See how there's no negative sign on it? That tells you it's positive. So we have a positive correlation that is significant between years of schooling and their socioeconomic index. Now, how you interpret this again is to say that as years of school go up, so does their SEI, or vice versa. I think it's probably that way. However you want to word it. Remember, keep your independent and dependent variables straight in your mind when you're interpreting these things. So, all right, cool, straightforward, right? Now we can add more stuff to it. Let me show you another thing too. There's one thing here that should probably give you some pause. See, these ends are different. 1496, 1423. That could be a problem later on, but I'll show you how to get rid of that later on. So, let's do another example, just like this. Analyze, correlate. All right, these are still in there. Let's add some more, huh? Let's see. How about age? That's a good variable. Just age, number of years from birth, right? Let's see here. Children's, ideal number of children is another one. Let's see. I'm always curious. I think number of siblings is always a good one. Why not? Right? All right. So we're going to go up to options here. Exclude cases listwise. See what that does. Keep it two-tailed. Keep flagging significant correlations. And hit OK. Now we can see that we have a larger table, but it's still the same thing. You still draw your imaginary line between the ones, or through the ones, I should say, and pick everything above it or below it. Now, I always pick above. That's my preference. But if you want to go below, again, it's the same thing. It's, if you folded it on top of each other using that line as one as the crease, these things would be the same thing. So just pick the ones you have. Now, what we did by selecting cases listwise is we only analyzed the 1,414 people that answered all four of these questions, which is really kind of what you want to do in the real world. And let's look at it. See, our highest year of school completed, we've already established. It's associated with our SEI. It's significant. It's just strong. It's 0.6. That's a pretty strong correlation. Remember, they only go from 0 to 1. And in social science data, let's be real, it really only goes from 0 to 0.7 or so, if you're lucky. So, yeah, 0.06, that's a strong correlation. So as education goes up, so does the SEI. We go to age of respondent. It's a little different, right? For one, it's got a negative sign. It's still significant, though. You see you have your little stars, and your p-value is 0.005, which, last time I checked, is indeed less than 0.05, which is always the cutoff. And so we have a scenario where, let's see, negative 0.05. So as years of school go up, age goes down. Or another way to put it, the younger somebody is, the more years of schooling they've had. It's an interesting finding, right? Now, you look at the R, it's 0.075, right? That's pretty weak. It's a pretty weak correlation, but it is significant. And again, think about why that would be. It's just one of those older folks didn't go to college at the same rate as younger folks, right? Or even graduate high school in a lot of cases. So it kind of stands to reason that this would make some sense. So yes, we have a negative association. As age goes up, years of education goes down, ever so slightly. Then we get the number of brothers and sisters. Again, it's negative. So the more education somebody has, the fewer siblings they have. It's a negative correlation. As one goes up, the other goes down. And it is significant, 0.000. You look at some other ones here, respondent SEI and their age. But look at the p-value there. That's 0.069. That's greater than 0.05, so this isn't significant. And when it's not significant, you just mark it off and keep moving. Don't interpret a non-significant result if you can avoid it. And you can't avoid it most of the time, so do that. SEI and number of brothers and sisters. Again, the more well-off somebody is, the fewer siblings they have. And it is significant, because that's your p-value, is less than 0.05. And finally, our last one is the age and number of brothers and sisters, and we see the p-value there is 0.101, which means it's not significant, and we can all move on. There you go. Now, let's take a look at the Spearman correlation. Let's go to Analyze, Correlate, Bivariate, and it's pretty much the same thing, guys. I'm going to reset it, and I will display the variable names. Now the difference is, now I'm going to use some ordinal measures. See if I can find some that I remember. Let's see here. Let's see. There's different ones here. Political views, right? This goes from conservative to liberal, right? But it's ordered, right? It goes ordered from conservative to liberal. It's not, there's no distance that we can actually measure, so it's an ordinal measure. That works for me. And income, as it's measured here, is actually measured in kind of categories, right? It goes from income from 0 to 20,000, and from 21,000 to 50,000, and 51,000 to 80,000, so on and so forth. Whenever you have it set up that way, where you have this kind of categories somebody can fit into, that too is an ordinal measure. Now, if we had measured it in just dollars, how many dollars they made, that would be interval. But this one is recorded as categories, so we'll stick that in there. And let's see, what else do we have here? I guess that's probably good enough for now to make their point. There's others we could probably stick in there if I knew for sure they would work. But the only difference when doing this test is you don't click Pearson, you click Spearman. That's it. That and the means and standard deviations just don't matter as much. And actually, it already takes it away from you here. Because if you're doing ordinal level measures, means and standard deviations aren't appropriate, right? So you don't need them. All right, Spearman, the two-tail, we hit OK. And voila. Let's go down here. Oops. Non-parametric correlation is that's kind of what it's called technically. And look here. According to this, there's no significant sig two-tail. That's your p-value. 0.209 or 289. That is larger than 0.05. So there is no relationship between income and political views, according to this. So, but if there were, I'm going to say for sake of argument and the sake of ending this video, you would interpret it exactly the same way as you did the one above. We did with the Spearman. If it's got a positive sign like this one or no sign at all, it means it's positive, which means as one goes up, the other goes up. For those that have negative, that just means as one goes up, the other goes down. And that's it. That, friends, is how you do correlation. And you actually get to use the word correlation, which is probably very exciting for some of you. Don't know why, but I guess it is. All right. Well, good luck and happy hunting.